Hi, my name's Mangahas, and I wanted to share with you some of the highlights of my technical and creative expertise. One of the things I'm capable of bringing to the team is my ability to create rich and vibrant presentations and learning supports for all varieties of learners. Here's an example of a project I worked on in creating a presentation to demonstrate the various ecological solutions to human global impact. I've created an online science curriculum through Oaks Online School using the Instructional Canvas learning management system. As part of this project, in addition to creating online science courses, I generated audiovisual lessons accompanying each instructional unit. And I also worked as an SME in collaboration with other technical experts. Here's an example of one of those instructional videos. In the next slide, we'll see an animation on how to use Punnett squares to determine the probabilities of future offspring using these Mendelian principles. Okay, so this is just a brief tutorial on how to solve a Punnett square problem with one trait. Now, typically in garden peas, as far as flower varieties, they come in two colors, purple and white. We'll symbolize them in this case with big P, little p. So if we have a problem that reads this, two parents are crossed, one that is heterozygous for purple color, big P, little p, and one that is homozygous for white color, little p, what ratio will their offspring have of white colors? Now we know that purple flowers are the dominant trait, white are the recessive. So the first thing we want to do is lay out the genotypes of the parents. We'll start with one, big P, little p, and that's the purple flowered parents. And we'll, on the side, put the genotype letters of the other parent, little p for white color. And this works just like a multiplication table. So we simply will draw in our letters right into the boxes. And we'll, in the first box, have big P, little p. In the second box, little p, symbolizing a white flower plant. Third box, again, little p, which is the recessive plant, and big P, little p. So our answer here will be that 2 of 4 of the expected offspring should have white flowers, meaning 50. Some of the other online learning modules I've worked on have included online learning curricula of diverse technical topics through Schoology, Moodle, and other online learning tools. Here's another example of an audiovisual lesson through this online learning platform.
So in Chapter 4, we discover the various properties of the element carbon. We pay particular attention to the types of bonds and the varieties of molecules carbon can form, not only with itself, but with other atoms as well. Carbon in general has 4 valence outer shell electrons.
One of the most interesting projects that I was given the opportunity to work on was taking on the role as the International Space Station project leader in facilitating the development of a biological payload in collaboration with scientists from the NASA Ames Research Center in San Jose, California, along with highly gifted youth, where I devised organizational charts, schedules, and instructional supports and materials from highly complex engineering and technical research papers and manuals. The project was completed in the spring of 2012 and was launched onto the International Space Station in February through a SpaceX rocket module. I've also generated learning materials in the area of astrophysics and engineering for advanced technical learners in collaboration with members from the astrophysics faculty of the University of California, Irvine, along with members of the Atlas CERN project from Geneva, Switzerland. Finally, a really fun project I've been able to embark upon to share to others my love for the science and technical fields is serving as a researcher and technical writer for a YouTube channel that seeks to promote literacy in the fields of science, technology, and gaming. Here's an example of a project that I worked on where I researched and wrote the script for a topic on cymatic frequencies in conjunction with modern technology and gaming.
Magic, to a lot of people, is simply a hodgepodge of various superstitions weaved together to generate myth or religious beliefs. It's sometimes referred to as a secret force which can exert effects beyond a physical plane of reality. But what is magic in the modern sense? Could it be sounds or frequencies which we can't see, that are capable of acting on things from a distance? What if sound made our reality? Plato thought the universe was based on forms or perfect aspects of everyday things, like tables, birds, or ideas. He believed that the world was geometrized and that the universe was based on some geometric plan. This same idea has been weaved into various ancient cultures, like the Egyptians, the Indians, Greeks, the Romans, and most recently in Stephen Skinner. Some of the earlier ideas even implied that music generated from harmonics could explain how the world came to be. Pythagoras, along with the Chinese, thought this, and even Kepler was inspired to base his laws of planetary motion on these 5 Platonic solids.
Well, that's all for now, but I do thank you for taking the time to watch this video, highlighting some of my skills, and I look forward to hearing back. Thanks.